Good morning, everyone. This is your math session. We are continuing polynomials, and this is the sixth part. And in this session, we are going to learn about algebraic identities and their applications. Since your 7th class, you have learned some identities, that is a plus b whole square, a minus b whole square, a plus b and a minus b. Now, first of all, we will see what is an identity. Algebraic identity is an equation that is true for all values of variables occurring in it. That is, whatever value you substitute for x and y, you will get LHS is equal to RHS. For even a single value, if it do not satisfy, we don't call it as an identity. Thus, identity is an equation which satisfies every value. Satisfies means after substituting, we will get LHS is equal to RHS. So according to that, the first identity we have learnt is x plus y whole square is equal to x square plus 2xy plus y square. Or you might have learnt it as a plus b whole square. It makes no difference. There a is the first term, b is the second term. Here x is the first term and y is the second term. Rather, the meaning of x plus y whole square is any binomial with plus sign in between. If it is multiplied by itself, then the product will have three terms, where the first term is the square of first term and second term is plus of twice the product of both the terms and third term is the square of second term. These are all addition, so you can write third term as second and second as third, as addition is commutative. So, instead of multiplying two binomials with plus sign in between, we can directly use this formula and write the three terms according to the terms in the binomial. Second identity is x minus y whole square is equal to x square minus 2xy plus y square. This means a binomial with minus sign in between is multiplied by itself. The product will be x square, that is first term square, minus 2 of first term into second term plus second term whole square. That means first term of the binomial is x here, second term of the binomial is y here. In the question, it may be replaced by any variable, any number. The same thing will replace in the formula also to reach the final answer. The third identity is x plus y into x minus y. That is, product of two binomials where first term and second term are same and one's plus is there and in the second bracket minus is there, or in the first bracket minus can be there, in the second can be there. It makes no difference. So product of two such binomials will be first term square minus second term square, or simply we can learn it as x plus y into x minus y is equal to x square minus y square, or we can say a plus b into a minus b is equal to a square minus b square. And the fourth identity is x plus a of x plus b is equal to x square plus a plus b of x plus ab. Here, two binomials are multiplied where the first one is the same, the first term of both the binomials are same, that is variable, and the second term is varying. Then the product is x square plus sum of the second terms into x plus product of the second terms. Now, when we write the identities as it is, they are said to be written as the product of x plus y and x plus y, x minus y and x minus y, x plus y and x minus y. But suppose we observe the product properly and we are able to identify there are two perfect square terms, both are positive, and middle one is twice the product of both, and plus term is there, then we can easily say that that is the square of a binomial where plus sign is there in between, and we can write it as x square plus 2xy plus y square is equal to x plus y into x plus y. This is nothing but called as factorization. When we write the product in the reverse order, the product is written as the product of two binomials, then those two binomials are called the factors of the product. This is known as factorization. Now let us see the geometric proof of a plus b whole square is equal to a square plus 2ab plus b square. That is, here is a square, is a geometrical shape. The side of the square is a plus b. All of us are learning that area of the square is side into side. So area of this square is a plus b whole square. Area is nothing but the space occupied by the given square of side a plus b. We see that on the one side area is a plus b whole square. On the other side, when the area inside is divided into various parts, depending on the a and b, it consists of two squares of different area and two rectangles of same area. Therefore, we say that this a plus b whole square is made up of a square plus 2ab plus b square. That is, the area of the square is made up of a square plus b square plus 2ab. Thus, we have seen that instead of multiplying a plus b into a plus b to get a square plus 2ab plus b square, geometrically also we have shown that a plus b whole square is equal to a square plus 2ab plus b square. This is known as the geometric proof. This proof is relating algebra with the geometry. Now let us see the geometric proof of a minus b whole square. Again, we have a square of side a units. Out of this square, small strips of b units are drawn in both the side lengthwise and breadthwise. When we do this, inside we get a square of side a minus b. If the square is of side a minus b, then that area of the square is a minus b whole square. So, how do we get that square, small square? If from the big square, we remove these two rectangles, yellow one and pink one, we get that a minus b whole square. Now, let us write a minus b whole square is equal to a square minus ab minus b of a minus b. That becomes a square minus ab plus b square. That becomes a square minus 2ab plus b square. Thus, the picture itself tells you that a minus b whole square is equal to a square minus 2ab plus b square. So, geometrically, you have to observe the square and rectangles that are in the square of a units, and you can write that or you can conclude it. Now, the third geometric proof is of a square minus b square. Now, the big square is of side a units. In that, let us take again a strip of b unit vertically and horizontally also take a small strip, that's how that it changes into a square of area b square. Now, from full square sheet, if we take away this b square, that is a square minus b square, what is remaining? This yellow one and blue one. What is this yellow one? A of A minus B plus B of A minus B. When we write like this, A minus B is common and the another term will become A plus B. So we understand that when from a big square of area A square, a small square of area B square is removed, the remaining part is A plus B into A minus B. Thus, geometrically also we have shown that A square minus B square is equal to A plus B of A minus B. Now let us start the applications of the identities we have learned. Before applying, the most important thing is you have to observe the question. You have to observe the question very carefully and then you have to ask yourself, it is in which form? And then apply that identity there. Here you need not multiply the binomials, but you have to identify the identity is in which form and then apply the identity here. The first question is x plus 5 into x minus 5. So here what do we observe? The identity is in which form? The first term and second term are same. One's plus sign is there and one's minus sign is there. So it is in form of a plus b and a minus b, or x plus y into x minus y. A plus b into a minus b is equal to a square minus b square. So this becomes first term square minus second term square. First term is x square minus second term is 5 square is equal to x square minus 25. Again, observe the second question. P minus 3, P plus 3. This is also in the form of a plus b and a minus b is equal to a square minus b square. P square minus 3 square. P is a variable, so we cannot find its square. We write it simply as p square. 3 is a constant. So 3 square means 3 into 3. We can write it as 9. So p minus 3 into p plus 3 is p square minus 9. Next question is y minus 1 into y minus 1. This is the product of two same binomials with minus sign in between. So we can write it as y minus 1 whole square. This is in which form, children? Yes, it is in the form of a minus b whole square, where it is a square minus 2ab plus b square. A square means here a is equal to y and b is equal to 1. So a square means y square, minus 2ab means minus 2 into y into 1, plus b square means 1 square. So this is equal to y square minus 2y plus 1. The fourth one is t plus 2 into t plus 4. This is in the form of x plus a into x plus b is equal to x square plus a plus b into x plus a into b. Here x is equal to t, a is equal to 2 and b is equal to 4. So t square plus 6x plus 8. When we substitute in the formula, we got this answer. Now next question is 102 into 98. Observe the question properly. 102, we are doing the multiplication since our third class. Here, nobody is supposed to do the multiplication normally. You have to observe the question and write it in the form of identity. So what we observe here? 102 is 2 more than 100. 98 is 2 less than 100. So what we are writing for 102? 100 plus 2. And for 98, 100 minus 2. 100 plus 2 into 100 minus 2 is in the form of a plus b into a minus b is equal to a square minus b square. So this becomes first term square minus second term square. That is 100 square minus 2 square. Whenever we do the square, first we see the number beside the zeros. 1 square is 1 and in square instead of 2 zeros we write 4 zeros. So 100 square is 10,000 and 2 square is 4. So 10,000 minus 4 is 9,996. Children, if you do the formal multiplication also, definitely you will get the same answer. In mathematics, whatever correct procedure you follow, you will get the same answer. But in this class, you are not supposed to do that. You are supposed to make the work easy and find the answer easily. Now let us see the first question of the exercise, that is 3x plus 2 and 3x minus 2. The difference between this sum and the before problems are, here the first term consists of coefficient also. Of course, this is in the form of a plus b into a minus b, but the first term is 3x. When there is coefficient, definitely you should insert that 3x in a bracket. Don't write this term which is having the coefficient without a bracket. So this becomes a square minus b square means 3x whole square minus 2 square. So the square will be applied to 3 as well as x. 3 square is 9 and x square remains as x square, and the answer becomes 3 square minus 4. 4 is nothing but 2 square. Thus 3x plus 2 into 3x minus 2 is equal to 9x square minus 4. Now, the next question is x square plus 1 by x square minus 1 by x square. Here also the same terms, first and second terms, one the sign is plus and then the sign is minus. So it is in which form, children? Yes. A plus b into a minus b. Simply first term square minus second term square. What is the first term? X square whole square minus 1 by x square whole square is equal to x power 4 minus 1 by x power 4. Now, few more problems are there in this question that you have to do by own. I am starting the second problem. Here also 999 into 999. No need of doing the formal multiplication. You have to identify it is in which form. You can write it as an identity and then you have to do it easily using an identity. So 999 multiplied twice means whole square. 999 is 1 less than 1000. Always we have to think of something less than or more than a 1000 or 2000 or 500 or 10 or 20 or 200. Some number that is along with the zeros beside it, that then the square of it becomes easy. In squaring such a numbers, we square the number, and instead of 2 zeros in square we write 4. Instead of 3 zeros in squaring we write 6. So the squaring becomes easy. So we write the nearest tens or nearest hundreds or nearest thousands. So 999 is nothing but 1000 minus 1 whole square. Now it is in which form? A minus b whole square. A is equal to 1000 and b is equal to 1. So 1000 square, a minus b whole square means a square minus 2ab plus b square. 1000 square minus 2 into first term into second term. 2 into 1000 into 1. Here dot represents into plus second term square, that is 1 square. So 1 square is 1. Instead of 3 zeros, we will write 6 zeros. And 2 into 1000 is 2000. 1 square is 1. Thus, we got the answer 9,98,001. Now let us see one more problem. 50 and half into 49 and half. Now the vision should tell you it is in which form. 50 and half is half more than 50. 49 and half is half less than 50. So a plus b, a minus b. 50 plus half into 50 minus half makes a square minus b square. 50 square minus half square. 50 square again, 5 square is 25. Instead of 1 zeros, 2 zeros. Always in square, there will be even number of zeros. And 1 by 2 square is 1 by 4. So 2500. If you take away 1/4, it is 3/4. 2499, 3 by 4. Now the next problem is Phi naught 1 into phi naught 1, that is phi naught 1 whole square. It is nearer to which number? 500. Let us write it as 500 plus 1. Now it is in which form? A plus b whole square is equal to a square plus 2ab plus b square. Here a is equal to 500 and b is equal to 1. 500 plus 1 whole square is equal to first term square 500 square plus 2 into 500 into 1 plus 1 square. Again square of 500. 5 square is 25. Instead of 2 zeros, we'll write 4 zeros in the square. And 2 into 500 is 1000 and 1 square is 1. So the answer is 2,51,001. So children, this is all about the applications of identities. I'll be giving you the assignment below this that you have to complete it and write all the slides in the classworks. And then whichever sum is left in the exercise, you do it by own. Today I have done only first and second question of that 2.5 exercise. Remaining problems you have to complete and keep your classwork ready for the next session. Thank you children. Stay at home, stay safe.